Okay, so we were discussing weakly coupled oscillators, and I think we've come to the end of that, and a few more things to needs to be seen. That one, that you can see that your x2 is always at a 90-degree phase difference with x1. This is quite clear from the graph. Secondly, one needs to see that your right mass is almost giving a driving force to the left mass. The right mass is almost giving a right uh, is acting like you can see that your x2 is acting as a driving force for x1. So your if this x2 is slightly greater than x1, what is happening? It is trying to like pull this particular mass in this direction with kx2 minus x1. Is that clear? So in any case, you can understand. Also from the graph, also it is clear. If you take the derivative of the graph, if you take the derivative of this graph, you'll get the velocity. So clearly this is sine, so the derivative will be cosine, and this is cosine, so derivative will be sine. Okay, and you can clearly see that they share a complementary relationship. That is, when it will be at maximum, this will be at minimum, and when this is at minimum, this would be at maximum. Is that clear? So in any case, understand the point that one thing is for sure, that x2 is almost is like a forcing oscillator to x1. Sorry, x2 x1 नहीं बोलना चाहिए. The right mass is a forcing oscillator to x1. Is that clear? And the right mass is doing some positive work on the left mass. However, the left mass is doing some negative work, because you can see that because left mass is coming here and because this is getting pushed there, so it will try to come in this direction. So the displacement, however, for the right mass is in the right direction, but the force would be in this direction. So f dot dx would be negative. Here you can see that f dot dx is positive. So this is what I feel. I mean, this is what I feel may be asked in the examination. Or you can say that there is a very abstractly saying that there is transfer of energy between x1 and x1 and x2 नहीं लिखना चाहिए, between right mass and left mass. Okay. Now in acoustics, like in sound waves, what do you say? That if two waves of same amplitude and almost similar frequency, you can say superpose, they give rise to something called as beats, to phenomena of beats. And you can see here that your omega s is almost equivalent to omega f. Is that clear? So omega s is almost equivalent to omega f. Is that clear or not? So basically what is happening? These two are only superposing, isn't it? So these two. So if you see omega s and omega f, they are not having much of difference. They're almost similar. So two of the frequencies which are almost close, and this A is, if it is having the same amplitude, like then it gives rise to a phenomenon of beats. So it gives rise to a phenomenon of beats. In acoustics, this is quite, you can say, quite common phenomenon. और what should I do? What should I say? मैं कैसे समझाऊं इस चीज को? ऐसे समझते रुक जाओ, यहाँ से समझने की कोशिश करते. So as I mentioned that x1 and x2, both of them are displacements of the left mass and the right mass respectively, and both of them are oscillating with almost similar frequencies. Frequency is almost similar, that is omega, because like epsilon is very, very less than this, and A is amplitude. A is amplitude. Is that clear?
Yes, sir.
Okay. And what is the frequency of beats? That is the difference between two minima, like two consecutive minimas. So this is how it is. The beat का मतलब क्या होता है? it will, in beats, what will happen, it will attain some maxima and then again it will die out and become zero. So this particular thing is called as a frequency of beat. This particular distance is called as a frequency of beat. So this is what I know from my 11th class, as much as I remember. So uh, so what should I do? What is the frequency of beat? I should write that the frequency of beat is frequency between what you can say ऐसा समझे इसको कैसे, जो इसको फ्रीक्वेंसी ऑफ बीट को समझने की कोशिश करते हैं. फ्रीक्वेंसी ऑफ बीट इज लाइक frequency corresponding to a frequency difference corresponding to sorry, corresponding to two consecutive zeros. So frequency difference between two consecutive zeros. So this is how it is. So between two consecutive zero, that is called as beat frequency. जितना मैं समझा पा रहा हूँ, समझ में आ रही बात, नहीं आ रही? So let's say ये तुम्हारा t equals to pi upon 2 epsilon है, और ये मान लेते हैं this will be like t equals to, ये कितना होगा, t equals to 3 pi upon 2 epsilon. So this difference is used for the is used for finding the beat frequencies. Okay, all of these things I may teach, probably it is not in the net syllabus as such, but I may teach in base part, but overall understand this is called as your beat frequency. अभी के लिए इतना समझो, this is called as your beat frequency. अब like time इससे निकल जाएगा, one can find the frequency also. So that will be equals to 2 pi upon this delta t, and delta t is the frequency difference between two consecutive zero. This will be 2 pi divided by, and that delta t would be equals to what? This will be equals to, I think, pi upon epsilon, because 3 pi upon 2 epsilon minus pi upon epsilon will give you pi upon epsilon. Pi get cancelled. This is your 2 epsilon. So this is what I understand as much. I know this is not a very comprehensive discussion, because I'm not, like, right now I'm not quite aware of what beats were. Whatever I know from my 11th standard, this is what I know the last. So it has been long that I have studied this topic, but overall this is how you can relate things. Okay, probably we may do beats. I don't know how much that is in our syllabus, but this much of idea would do. I mean, this much of idea would do. Otherwise, I would recommend reading you some sort of book on waves and oscillations also. So that may help probably. Is that clear?
Yes, sir.
And there are a lot of simulations on internet. You will find like guitar, they do kind of some guitar
Yes, sir.
simulations, and all those things you'll find in beats. So that is more helpful than whatever I'm going to teach, because I may not be able to picturize it completely in quite physical sense. So only mathematically I can say that this is the frequency, and like this is kind of definition. But in order to realize it, I would recommend that you see some sort of simulations on internet, and there are very good videos also on beats. So that may help you a little bit more to realize it physically. Is that clear?
Yes, sir.
And coupled oscillators, we'll do a few more cases only, probably one lecture or two lecture only, not more than that. And then we may do some sort of oscillations only in this Newtonian and oblique Lagrangian mechanics. Let us do one problem today, and then we'll. And also let me know that if, because now what I'm thinking is to do again electromagnetic theory and linear vector space. So electrostatics and linear vector space. So that linear vector space एक बार हो जाए, then we should start with quantum mechanics. So that थोड़ा सा maths वाला touch रह जाए. और is that fine? मतलब तुम बता सको तो बता दो.
Yes, sir. It's fine, sir. Maths so important है, sir.
अभी तक समझ में तो आ रहा है ना, ऐसा कुछ अटक तो नहीं रहा. जैसे इसका प्रॉब्लम यही है कि ये बहुत पहले पढ़ा हुआ है मेरा. So, जितना मुझे
जी.
समझ में आता है उतना मैंने लिख दिया, राइट? इसको
हाँ जी,
तुम
sir.
एक बार सिमुलेशंस में जरूर देखना. सो springs on circle. So now if thoda sa case ko change kar de, rather than being on one like line, I'm now using two identical masses. I'm now using two identical masses. All of these problems again we are going to see in Lagrangian also, so don't worry about it. I'm just trying to make you familiar with both Newtonian as well as Lagrangian mechanics. So right now I'm doing Newtonian mechanics because I'm more concerned with my force, right? Here you see this is kind of Newtonian way of dealing things, that you write the expression of force and write the expression of force equated to mass times acceleration, and this is how your dynamics goes in your uh, Newtonian sense. But in Lagrangian and Hamiltonian mechanics, energy takes the uh, front seat. So I'm teaching you both because I don't know what clicks in examination, and this is a really tough topic. मतलब जनरली लोग इसको नहीं करके जाते, या करते भी हैं तो वही selected questions कर लेते हैं. Then I believe कि जितना हो पाए ठीक ठाक कर लेते हैं. Okay, this is why.
सर
हाँ बेटा बोलो.
सर ये जो ऊपर वाली प्रॉब्लम थी इसमें हमने फ्रीक्वेंसी क्लूज लेने का कोई रीजन है? मतलब कि जो कप्पा हमने स्मॉल लिया है के से,
हम्म.
उसका कोई रीजन है? मतलब कि अगर वो हम डिफरेंट लेंगे अगर कुछ तो
अगर हम
क्या डिफरेंस?
different लेंगे तो probably I will say कि we will not be able to produce some probably good physical result as such, because then both of these things will start dominating, right?
राइट
uh,
राइट राइट.
है ना. अभी इसके अंदर एटलीस्ट वी आर एबल टू से some sort of like physical कुछ चीज तो हम समझा पा रहे हैं relevant, like this is, मतलब ये मैं जितना याद है मुझे, this is something what you find in acoustics. मतलब जैसे वो
यस सर.
स्टैंडर्ड बीएससी में वो जब हम पढ़ते हैं ना, वो गिटार की वो जो होती है कि
यस
क्लोज
सर,
फ्रीक्वेंसीज में
स्पेक्ट्रम
ही
ऑफ साउंड.
साउंड है ना. मतलब somehow this is a kind of physics that we can probably that would have also been studied, like वो भी पढ़ा तो गया ही होगा ना. कि
यस सर.
अगर ये इस कम like this is what I know makes some sort of physical sense which can be discussed. Okay, otherwise I
ओके.
believe to, और ऐसा नहीं होता because nature is nature. मतलब nature तो nature है, because there is not always these kind of like
यस
waves,
सर.
or you can say that not always these kinds of waves which will have almost similar you can say frequencies. That you are absolutely right about. Probably let's say seismic waves. Okay, so ऐसा नहीं है कि नेचर में ऐसी स्टडीज नहीं रही होंगी कि where your waves, if they are not very close enough, and then what sort of physical implication they may give rise to. But probably this is a physical implication which we are quite familiar, or probably physicists are quite familiar with the classical physics of Newtonian's classical physics, or something like that. That is why you find the mention of all these things in your books.
यस सर.
Otherwise, I think
ये
that would be okay. So this is the only reason, like, this is the only reason I have. Okay. So if I take springs on the circle, and all those things are fine, that like these are connected by two springs. This is your identical mass. Obviously, this is on the frictionless. You can say that this particular circle is like you can take a piece of metal, and this is frictionless, so that all those dissipative forces do not come into place. And we want to find the normal modes associated to this normal modes associated. So you want to find normal mode associated. If these two masses are constrained to move, if these two masses are constrained to move on this circle only. इसमें में बहुत मात्रा अच्छी होती है, but somehow I'll try my level best to explain. ठीक है, चलो देखते हैं. So what will happen? Let us take हम लोग जैसे करते हैं वैसे ही करते हैं. हम लोग एक mass को थोड़ा ज्यादा displace करते हैं as compared to the other mass. Okay, so I'll do what? Let's say this is my equilibrium position, and I will displace this mass slightly lesser than this mass. Okay, so let us take that this mass is also is making a displacement x2, and this is making x1, with the condition that x2 will be greater than x1. What will happen? what is the net elongation oblique compression, whatever. Here it will again be x1 minus x2, and here also it will be again x2, x1 minus x2. Is that clear? The only difference is this spring, that is what, इसको थोड़ा ढंग से लिख देते हैं. This spring that I'm talking about, what should I say? Like, I'm saying x2 minus x1. I'll take a mod so that I do. Right now, I know that x2 is greater than x1. So this will get compressed. This particular portion will get compressed. And this particular portion will get elongated. Is that clear? Because see, ये x2 आगे जा रहा है और ये x1 आगे जा रहा है और x2 आगे चला गया, and x2 is greater than x1. So obviously this particular spring will get stretched, and this particular part of the spring will get compressed. Or you can, what should I use the word? Compressed only. Say it. Is that clear? And I know that whenever you have अपन एक काम करते हैं, let us take the increasing directions of, like, in whichever direction our masses are moving, let us take that direction to be an increasing direction, so that there should be no sign discrepancy as such. Is that clear? So what will happen whenever your springs are compressed, like your masses coupled by springs are compressed, they feel a force in opposite direction by Newtonian third law, action reaction. And if they're elongated, like the spring is elongated, and now these masses are here, so they feel force in this direction. Is that clear? So since now this is compressed, it will feel a force in this direction, and this will feel a force in this direction, given by, and you take both constants k for simplicity right now. We are not going to get involved in all sort of weak coupling, ये सारी चीजें. So ऐसा होगा कि whatever I understand, this will feel a force of k x2 minus x1 mod. If you want to take, even if you don't want to take mod, it is fine, because x2 is obviously greater than x1. Is that clear? So this is due to this part. Okay. So ऐसा कर देते हैं, इसको ऐसा बना देते हैं. ये compressed वाली spring मैंने red से बना दी, ठीक है? So I made the compressed spring by red. Okay, and I'm writing with red only so that confusion ना हो. कम से कम हमारे पास कुछ facility तो हम उसको use क्यों ना करें. So you filled the form of this year's net, or did you not fill the form? I mean, just asking.
Yes, sir.
But my promise is to teach till December, like for the December attempt, because right now I'm quite occupied with my research work now. But in any case, by December I'll finish off your course. That is my promise. That is for sure. Is that, ये तो भारत का झंडा लग रहा है थोड़ी देर में. ठीक है, so this gets elongated, this gets elongated, and since it gets elongated, so I told you whenever spring gets elongated, it feels like if I can make you understand, if it gets elongated, it will feel force in this direction. So if it gets elongated, this particular mass will again feel a force in this direction only, and that would be k x2 minus x1, and this will also feel force in this direction only, k x2 minus x1. Is that clear?
Yes, sir.
So now let us write the differential equation corresponding to both of them. So m x1 double dot, and this is the increasing direction of x1, or इसी direction के अंदर you can find that your forces are. So I'll simply add them up. Is that clear? So in other words, I will write mx1 double dot minus, I'll write 2, so इसको ऐसा कर देते हैं 2k x1 minus x2 equal to 0, और एक लिख देते हैं mx2 double dot, that will be अब थोड़ा ध्यान से देखते हैं mx2. So x2 की इंक्रीजिंग डायरेक्शन क्या थी, ये, बट फोर्स किधर लगता है, इधर. So I will write minus 2k, इसको ऐसे लिख देते हैं, पहले ढंग से लिख देते हैं, इज इक्वल टू माइनस k x2 minus x1 एंड अगेन माइनस k x2 minus x. ये समझ में आया नहीं आया? देखो, ये मैंने मानी इंक्रीजिंग डायरेक्शन ऑफ, जो मतलब जो जिस डायरेक्शन में मास चल रहा है उसको मैंने पॉजिटिव डायरेक्शन बोला, तो उसके ऑपोजिट ही लग रहा है. इज दैट क्लियर? मतलब आपका मास का डिस्प्लेसमेंट इधर है, फोर्स इधर लग रहा है. सो दिस लाइक x2 डबल डॉट विल बी अगेन 2k x2 minus x. अच्छा, ये दोनों के x2 minus x में आता है क्या? नहीं, यहाँ x1 minus x2. ठीक है, तो ये हो गया इक्वेशन नंबर 1. दिस इज योर इक्वेशन. ठीक है. नाउ हियर यू कैन सी दैट योर अप्रोच 1 वुड वर्क बेटर, बिकॉज अदरवाइज ट्रायल सॉल्यूशन लोगे, अल्फा स्क्वायर और बहुत सारी चीज करने से अच्छा सीधे ऐड और सबट्रैक्ट कर लो. सो ऐड 1 and 2 you will get m x1 double dot plus x2 double dot is equals to क्या आना चाहिए 0. ठीक है, क्योंकि ये 2k x1 minus x2 and 2k x2 minus x1 will become 0. So this is your equation number 3, and subtract 2 from 1. ठीक है, subtract 2 from 1. So what you will get? You'll get m x1 double dot minus x2 double dot plus what should I write? What should I write? What should I write? So I'll write 2k x1 minus x2 equal to 0. So here you will get, I think, ये 2k आएगा या 4k आएगा? 4k. 4k. So this will become x1 double dot minus x2 double dot plus 4k upon m x1 minus x2. ठीक है, तो ये हो गया तुम्हारा काम खत्म. So you have two equations. Now this particular equation is simply suggests that x1 plus x2 would be some linear function, isn't it? Because if you understand that the equation for the straight line is y double dot equal to 0. So basically यहाँ पे क्या हो रहा है? x1 plus x2 double dot equal to 0 आ रहा है. So this will be this, and x1 minus x2 I can write it as c cos 2 omega t plus some phi, where omega is given by root over k form. Is that clear?
Yes.
So if I want to solve these two equations, or otherwise if I want to write it in very compact matrix form, I'll write in this fashion. कैसे लिखेंगे इसको? एक बार 1 minus 1. So I'll write it in, ऐसा कर देते इसको 1 1 80 plus b, and then I will write 1 minus 1, and I will write the c cos 2 negative. ठीक है. So if you write x1 as a function of t, this is 80 plus b plus c. तो देखो ना, इन दोनों को ऐड करोगे तो क्या आएगा? x1 आ जाएगा, और इन दोनों को सब्ट्रैक्ट करोगे तो क्या आएगा? x2 आ जाएगा, इसलिए मैंने यहाँ माइनस. Is that clear?
Yes, sir.
So x1 plus x2. So why I have written this in this fashion? See, these are two possible independent motions that can happen. So this is one normal mode and this is another normal mode. So one of the normal mode is 1 1, corresponding to a non-oscillatory motion, or you can see that corresponding to motion with zero frequency. Okay, because this is linear, this is completely linear. However, the mode corresponding to 1 minus 1 will oscillate with a frequency 2 omega. Is that clear? So basically, in the first case, you can see if the motion is linear, that only implies that there is no as such involvement of spring. These two masses are just sliding. Is that clear? Because it represents that rate of growth of motion is like rate of growth is only time dependent, linearly dependent time. So there is as such no involvement of these springs there. So basically, हो क्या रहा है? एक तरीके का with respect to time, this is also increasing. With respect to time, this is increasing. Is that clear? यही तो हुआ?
Yes.
है ना? And like this particular mode only is represent that your masses are just sliding, nothing else. Just sliding in linear fashion, linear rate, at a linear rate on the what you can say on the hoop or whatever, on the beat, on the hoop, on the. Okay.
Yes.
In this particular case, this is an oscillatory motion. This is an oscillatory motion, and here you have this kind of involvement of spring. So there are two different possible motions. So one of the normal mode corresponds to one of the normal mode corresponding to the normal coordinate x1 plus x2 corresponds to a motion with zero frequency. Another normal mode corresponding to 1 minus 1 given by normal coordinate x1 minus x2 represents an oscillatory motion with frequency 2 omega. Okay. Is that clear or not clear? Okay. So this is what I mean. It may be asked in this fashion also. मतलब होता क्या है कभी-कभी if the examiner is to say, मतलब करेंगे क्या, एग्जामिनर पूछना चाहता है ऐसा पूछ लेगा, तो वो थोड़ा सा ऐसी चीज को थोड़ा फिजिक्स वाइज बना के पूछ लेगा, अदरवाइज कोई नहीं। और here you will find that there is an involvement of spring, here there is an involvement of spring, मतलब like मतलब यहाँ पर springs are involved, only then you can find some sort of oscillations because of this restoring nature of the spring force. Okay, but if AT plus B है तो खुद सोचो AT plus B का मतलब क्या हुआ, AT plus B का मतलब if your whatever coordinate is giving you AT plus B, so इसको पूरे को अपन Z लिख देते हैं, तो Z as a function of t is AT plus B, it implies what, इसका डेरिवेटिव करोगे तो इसकी स्पीड कैसे आएगी, कांस्टेंट स्पीड नहीं आएगी, बेसिकली मास m1 and m2 are sliding with a constant speed, nothing. इज दैट क्लियर। और इधर क्या होगा, इधर ऐसा होगा कि अगर ये मास लेफ्ट की तरफ मूव कर रहा है तो ये मास भी लेफ्ट की तरफ ही मूव कर रहा होगा, ओनली इन दैट केस देयर वुड बी सम कंप्रेशन, आर यू गेटिंग माय पॉइंट, ओनली इन दैट केस यू विल फाइंड सम सॉर्ट ऑफ इन्वॉल्वमेंट ऑफ स्प्रिंग। और अदर वे राउंड, अगर ये राइट में मूव कर रहा है तो ये भी राइट में ही मूव कर रहा होगा, तभी जाके कुछ कंप्रेशन आएगा, और जितना इस स्प्रिंग में कंप्रेशन है उतना उस स्प्रिंग में एक्सटेंशन हो जाएगा। तो मैं समझा पा रहा हूँ, नहीं समझा पा रहा हूँ, ये चीज
यस
समझ
सर,
में
यस सर।
है ना। सो दिस इज हाउ इट कुड बी, लाइक दिस इज व्हाट आई फील, दिस इज व्हाट आई फील, बाकी तो फिर ठीक है। सो बिकॉज ऑफ दिस व्हाट विल हैपन, द फ्रीक्वेंसी विल कम आउट एज, व्हाट इज द फ्रीक्वेंसी ऑफ ऑसिलेशन, रूट ओवर, इट वाज आई थिंक, कहाँ गया वो, फ्रीक्वेंसी ऑफ ऑसिलेशन वाज 4k अपॉन m ना, तो 4k अपॉन m का मतलब क्या हो जाएगा, इट विल बी 2 टाइम्स, राइट, सो इट विल बी, ऐसे लिख देता है, इट विल बी 4k अपॉन m, so this is your frequency of oscillation for the second mode, you can say. The first mode frequency was 0. The second mode's frequency is 2 times the natural frequency, and which should be the case. Because अगर ये एक ही स्प्रिंग से होता तो ओमेगा आता आंसर, बट हुआ क्या, दो स्प्रिंग्स है, तो एक में अगर x का डिस्प्लेसमेंट आएगा, दूसरे में अपने आप x का एलोंगेशन आएगा, मतलब एक को अगर तुम x से कंप्रेस करोगे तो दूसरा अपने आप ही x से एक्सटेंड हो जाएगा, तो टोटल डिस्प्लेसमेंट हो जाएगा तुम्हारा 2 टाइम्स, लाइक व्हाट शुड आई से, मतलब जैसे कि अगर तुमने इसको x आगे लेके गए, जैसे इसको तुम x आगे लेके गए तो ये भी तो x आगे आएगा, तो इवेंचुअली इसके अंदर 2x हो जाएगा, और जैसे ये x आगे गया और मान लेते हैं ये भी x आगे गया, ऐसे समझो, चलो मैं ऐसे समझाता हूँ, जैसे मान लेते हैं इन दोनों को हम लोगों ने x x मूव मूव किया, x इसको मूव किया और x इसको मूव किया, ठीक है, लेफ्ट के अंदर। सो टोटलिटी में इसके अंदर कंप्रेशन कितना जनरेट हुआ, 2x इस स्प्रिंग के अंदर, और राइट हैंड साइड वाली जो मैं ऐसे बना रहा हूँ, राइट हैंड साइड वाली जो है उसमें टोटल कितना कंप्रेशन हो गया, उसमें कितना एक्सटेंशन हो गया, 2x नहीं हो गया। In totality, each of these are subjected to force 4kx. So yeah, this result was obvious. मतलब this result should have come. मतलब intuitively अगर तुम सोचो थोड़ा सा कि springs का involvement का मतलब क्या है, both of them must be moving towards each other. Only in that case springs will get involved. Otherwise क्या है, अगर ये भी x से चल रहा है, ये भी x से चल रहा है, तो अच्छी बात है, फिर क्या प्रॉब्लम, फिर तो linear rate है ही। बट अगर ये x से इधर चल गया और ये x से इधर चल गया, in that case the spring will get compressed. Or by what amount? Let's say this moves by x and this moves by x, so this will get compressed by an amount 2x. And since this spring gets compressed by 2x, so this spring will get elongated by 2x, isn't it? क्योंकि इसको x आगे जाना तो यहाँ से खींचा होगा, और इसको x आगे जाना तो x यहाँ से खींचा, तो this will get elongated by 2x. Is that clear? And because of this elongation, this particular 4kx इस पे भी लगेगा, 4kx इस पे भी लगेगा. I'm not very sure of directions right now because वो मैंने बनाई नहीं, but overall understand each of them, each of these masses will be subjected to a force 4. Each of these क्या कह सकते हैं, masses m1 m1 m2 मतलब each of these masses will feel a force of 4kx, which indeed you can see in the expression also. Is that clear?
यस सर।
मैं मतलब वो थोड़ा 11th क्लास वाली बात समझा रहा हूँ, बट ओवरऑल अगर 11th क्लास में नहीं समझ में आती तो सामने दिख ही रहा है, बस अंदर पता है। अच्छी बात, मैं तुम्हें वैसे मेरी पर्सनल बात बताऊं, बस होता क्या है, 11th तक की फिजिक्स क्या परसीवेबल है, मतलब दिखती है वो होते हुए। जैसे जैसे वी ग्रो ओल्डर, आर फिजिक्स बिकम्स मोर मैथमेटिकली इंट्रिकेट एंड लेस परसीवेबल।
राइट सर।
हाउएवर देयर इज अ ब्यूटी अबाउट इट आल्सो, मतलब ठीक है, हमने आपको सोल्यूशन लाके दे दिए, एक ऑसिलेटरी होगा और एक लीनियर होगा, बट दैट ब्यूटी गेट्स समहाउ destroyed with the mathematical intricateness. So this is what I was talking to Alpna yesterday also. Ki somehow if somebody generates simulations to all those things, because I have seen many such YouTube teachers also, and they're good also. One of the channels I would recommend, I saw yesterday only, that channel is called as For the Love of Physics. The guy is teaching exceptionally good, and he's making some sort of simulation. Or he's teaching very good. Uh,
Yes
so,
sir, I've seen this.
हाँ मतलब
Walter
he's doing.
Levin.
हाँ नॉट वॉल्टर लेविन तो चलो वो तो एमआईटी का हो गया, दैट इज अ बुक ऑफ हिम. एग्जैक्टली तुम उसको सर्च करना, द सेम नेम फॉर द लव ऑफ फिजिक्स, ही इज सम बंगाली गाय. ही इज टीचिंग गुड, मतलब ही इज टीचिंग एंड ही इज टीचिंग विद ऑल सॉर्ट ऑफ this thing. I'm right now not having that amount of time कि I will do this, but somehow I felt कि if those simulations can run and somehow you know, अब ये चीज मैं समझा रहा हूँ, ये चीज अगर सिमुलेशन में दिखती है ना तो बहुत परसीव हो जाती है फटाक से. I hope समझ में आया होगा. Tomorrow we'll start anyway linear vector space, that is for sure. And another thing probably I will start is either Legendre polynomial, and if you can study on your own थोड़ा सा Legendre polynomial, still the generating function. मैं वैसे पढ़ाऊंगा Legendre polynomial, don't worry about it. But अगर थोड़ा सा generating function तक पढ़ सकते हो, तो we'll start multiple expansion. So हमारा मल्टीपोल एक्सपेंशन रह गया ना, तो लैप्लेस इक्वेशन में, लैप्लेस इक्वेशन में क्या रह गया, मल्टीपोल एक्सपेंशन और इमेज मेथड, राइट. सो
Yes sir.
है ना, तो इसलिए मैं कह रहा हूँ कि अगर तुम लेजेंडरी पॉलिनोमियल के जनरेटिंग फंक्शन से कंफर्टेबल हो, देन आई विल सीधे स्टार्ट मल्टीपल एक्सपेंशन. एंड इफ यू वांट कि मैं लेजेंडरी पॉलिनोमियल पढ़ा दूं पहले, देन आल्सो आई कैन मूव टू दैट पर्टिकुलर क्वेश्चन. एनीथिंग वुड डू. आई होप इट इज क्लियर टिल नाउ.
Yes sir.
विल मेक इट स्लाइटली कॉम्प्लिकेटेड, बट थोड़ा सा we'll do it tomorrow. Okay, is that clear?
हाँ जी सर. सर
Okay, okay.
लेजेंडरी अलग से पढ़ने की बजाय मेरे ख्याल से हम उसकी एप्लीकेशन में पढ़ेंगे तो ज्यादा क्लियरली समझ में आएगा,
हाँ
नहीं
हाँ
तो
हाँ,
पूरा फिर मैथमेटिक्स सब जाएगा.
कोई दिक्कत नहीं, पर एज सच स्पेशल फंक्शंस नाम का टॉपिक है तुम्हारे सिलेबस में, और वो हर साल उधर से क्वेश्चन फिक्स आता है, सो वो तो करना ही करना है इन एनी केस. बट ये है कि अगर लेजेंडस पॉलिनोमियल कैन बी जनरेटेड यूजिंग अ जनरेटिंग फंक्शन, एंड दैट जनरेटिंग फंक्शन इफ आई से एंड इफ यू कन्विंस योरसेल्फ कि ये अच्छा ऐसा होता है, देन मल्टीपल एक्सपेंशन यू कैन डू. ओके.
फाइन सर. यस.
ओके चलो चलो, टेक केयर, वेलकम.
थैंक यू सर.
ओके.